Okay, ji. So circle properties. Before we just start off with circle properties, there are a few things that you need to keep in mind. Number one is that circle properties will be involving circles because obviously it's the major thing. Now, knowing the fact that there will be a center of the circle as well, when there will be a center of the circle, so the line, the circumference, that means the perimeter will be the circumference. This will be your circumference. That means the border of the circle is known as circumference. Whereas this point is the center of circle. This thing is center of the circle. A line from the center of the circle to the circumference to one point on the circumference is known as your radius. A line that connects two points on the circumference and crosses the center of the circle is known as your diameter. A line that connects 2 points on the circumference, and does not cross the center of the circle is known as chord. So that particularly means that this is the circle that involves is your circumference. This point is your center of the circle. This line, when meets the center of the circle and one point on the circumference, is known as your radius. A line that connects 2 points on the circumference and crosses the center of the circle is known as your diameter. A line that meets 2 points of circumference but does not cross the center of the circle is known as your chord. Now, a chord can even be closer to the diameter line like this. This line is meeting the 2 points on the circumference, but if you note, it is not crossing the center of the circle. Since it is not crossing the center of the circle, this line will still remain chord. So this is known as your chord as well. So the reason for this is because it is not crossing the center of the circle. So if a line that meet the 2 points on the circumference but does not cross the center of the circle will always remain chord, irrespective of the fact that, however, even if it is closer to the center of the circle. Since it is not crossing the center of the circle, it will not become your diameter. It will still remain your chord. So all the properties will be linked from the circle. Now, continuously, if you see that property number 1 can be known as your isosceles property. Now, what does isosceles property do? Isosceles property is when two radius and a chord meet, it creates a isosceles triangle. It creates an isosceles triangle. What does isosceles triangle do? Isosceles triangle do when two sides are equal. Then two opposite angles will be equal. So the two sides here will be your radius. Now, knowing this fact, let's just work upon the circle again. If I say that this is your circle This is your circle. And in this particular circle, there is a center of the circle as well. In that center of the circle, we can see that this is your radius. Obviously, it is connecting center of the circle and point on the circumference. There's another radius. So these two radius will be same because the length is same. And when these two radius meet the line which is known as your chord. So if you see, it creates a non-right angle triangle. But obviously, this non-right angle triangle is your isosceles triangle. When this becomes your isosceles triangle, what we understand is that the angle opposite to the same side will be equal. That means if these two lines are same, then opposite angles will be same as well. If this is x, then this should be x as well. If this is 30, then this should be 30 as well. If this is 40, this should be 40. If this is 50, this should be 50. Some of the triangle will remain what? 180 degree. Some of the triangle will remain 180 degree. So if this is 30 and this is 30, so 30 plus 30 will be 160. Then obviously 180 minus 60 will be what? 120. So isosceles triangle will always create what? Two sides are equal, then two opposite angles will be equal, and the sum of the triangle will remain what? 180. So which means if this is x, then this will be also x. And this should be 180 minus what? 2x, or the value of x, right? So considering the fact that we know that this should be 180 minus 2x. So the sum of the right angle triangle x plus what? This should be normally known as, let's say, y. So this should be y. The sum should always be equal to what? 180. So y is equal to what? 180 minus 2x. So we can always get the angle as well. So your first property is isosceles property. Now, let's just work upon the extended version of the isosceles property, that how can you think about the isosceles property in the other regard. Now, let's just work upon that. We have been given an angle. Let's say this is your circle. Now, considering that this is your circle, let's take this as your center of the circle. And we knew that this was your radius. This line was your radius as well. And this becomes your chord. Knowing the fact that these two lines are equal, then obviously then those two angles will also be equal. So if the shape is extended from the center of the circle with the same line known as your diameter, and let's say it meets here. So even at this point of time, you need to understand that this and this line will also be equal. Because again, this is your radius, knowing that this becomes your radius. So if this is your radius, then this should be radius as well. So even if this is 30, then this angle should be 30 as well. Knowing this, that if let's say this angle is 120, then straight line makes up what? 180 degree. This side should be what? 60 degrees. Since this side is 60 degree, so this angle should be 60 and 62. But let's just change the particular angle so that we can get the answer. Let's say that this is 40. Let's say this is 40. Considering this as 40, I need to find this angle. Let's say this is y. So if this angle is y, and I need to use the isosceles property, there you can get another, you can use another type of property to get this answer as well. But particularly, I'm using the isosceles property right now. So at the moment, what we can work upon is that if this is 40, we can easily say this angle is also 40, right? If this angle is 40, so let's say this thing should be 40 plus 40 is 80, subtracted by 180, you will be getting what? 100. Because the sum of the triangle is always 180. Straight line makes up 180 degrees. So if this is 100, so we can say that 180 minus 100 will be what? 80. Now, if this is 80, we already know that these two lines are isosceles triangle, and knowing as radius, then the opposite angles will be same. If this is y, then automatically this should also be y. So if this is y, that means this is another type of triangle, knowing that it is an isosceles triangle, but this is another triangle. So considering it as y plus 80, and this should sum up of what? 180 degree. So this should be 2y is equal to 180 minus what? 80. Knowing that 2y is equal to what? 100, this should be y is equal to what? 50. So knowing this, that considering that from one particular triangle, an isosceles triangle, I can extend my angles to the other isosceles triangle as well to get the answer of what? If this is 50, this angle can also be what? 50. So this is the extended version of the isosceles property. We also know that the answers can easily be taken out through using the other properties as well, but particularly we were discussing the isosceles property right now. Now let's work upon the second property, which is diameter meeting two chords. Which is diameter meeting two chords. Number one, a diameter is a line which connects two points at the circumference and also crosses the center of the circle. A diameter is a line which connects the 2 points on the circumference and also connects the center of the circle. A chord is that only connects the 2 points on the circumference. Considering that diameter meeting two chord, this is also known as angle in a semicircle. Angle in a semicircle property. So when it says that diameter meeting two chords or angle in a semicircle, we will always work upon, let's say we have a circle again, right? So if this is your circle, let's just work upon the center of the circle. Now, considering that this is your diameter, knowing that this is your diameter, because in diameter, you know that it connects the circumference point and also crosses the center of the circle. And we are putting forward two chords. If you see, this is your first chord. Let's say this is your second chord. And what does chord do? That means this chord, two chords are meeting at one particular point. So let's just understand this. So what does the property say? The property says that when two chords meet at separate end of diameter, and chords meet at a point on circumference. At that point, it creates 90-degree angle. That means this angle where the two chords meet. If you just notice one particular thing, this is your semicircle, number one. This is your semicircle. And in the semicircle, you are connecting two chords at the point on circumference. Those two chords are also meeting at the point on the diameter, right? Two separate points on the diameter. So when two chords are meeting at the circumference. At that particular point, this will create what? 90 degrees. So this is your property connecting, knowing the fact that when two chords meet at a point on circumference and those two chords are also meeting at two separate points of the diameter, it will create a 90-degree angle. It will always create a 90-degree angle. But particularly, it will be in the shape of what? Semicircle. That means it will be inside the semicircle as well. So let's just work upon the same. We did the isosceles property initially. If you just look at this, we can easily see that this is your diameter. This becomes your chord and this becomes your chord as well. So this thing was creating what? 90 degree. How? We got this 40 degree and you saw that y was what? 50 degree. So 40 plus 50 becomes what? 90 degree. If you knew this property earlier, or obviously you knew it already, you know when the two chords meet at a point of circumference, it creates what? 90 degree. Then you could have easily found out this y as 50. So if this would have been 50, then this particular angle would have been 50 as well. So this is another way of finding out the angle if you knew the properties very well. So isosceles property, we already found out the same angle using the isosceles property. But now we connected it with what? We connected it with when the diameter meeting two chords, or angle in the semicircle property, where two chords are meeting at the point of circumference, and at that particular point, it creates a 90-degree angle. It creates a 90-degree angle. We can even take further examples of such property as, let's say, if this is your circle, let's make this as your circle, a rough handed circle it is. This is your diameter. And let's say this diameter meeting two chords here. This is your two chords. So at this point, this will create what? 90 degree. And if you just look at this is your semicircle as well. And in this semicircle, the two lines of chords are meeting at the point of circumference and connecting your diameter. So this point should always be what? 90 degree. Now, in any particular form or any particular way, when the two chords will meet, let's say here, this is your circle, and let's say this becomes your diameter. And at this point, see, let's say these are the two chords meeting at the circumference. So is this again meeting in what? A semicircle. So this is what? Your angle in the semicircle where two chords meet, and where the two chords will meet, it will always create what? A 90-degree angle. Before we move to the third property, we need to understand a tangent line. A tangent line is a line. It is a line which will meet at one point on circumference. It will meet at one point on circumference, but it will go through, or it will go from outside the circle. That means it is an extended line that will meet from outside the circle. So just the random circles I'll create. So this is a circle, considering that it is a circle. It's a rough-handed circle. Center of the circle is there. If you just look, a line that can cross, it will meet at one point and it will cross from the outside of the circle. Let's just say, let's create another circle. This is the center of the circle. Let's say a line is meeting at one point and it is going through the outside the circle. So this is known as your tangent line. Similarly, let's just work about another circle, and this circle is going to meet a tangent, but this tangent is going outside the circle. So obviously this will be known as your tangent. So your tangent passes through the outside the circle, but this will always touch one point on the circumference. This will always touch one point on the circumference. You already know what was radius. A radius was the line. A radius was the line that connected what? That connected center of the circle and one point on the circumference. It connected center of the circle and one point on the circumference. It connected center of the circle and one point on the circumference. So looking at the concept of this, you need to understand that what will be the radius and the tangent property. Your radius and the tangent property will be your third property, where radius meets tangent. Now, you need to understand when radius meets tangent. When radius meets tangent, when radius meets tangent, it creates perpendicular angle, which means it creates 90 degree. It creates 90 degree at point of tangent. At point of tangent. Let's just work upon it. Let's say we have a circle again, right? And at this particular circle, there is center of the circle. And let's say this is your tangent meeting one point on the circumference. And this tangent is particularly meeting the radius. So when this tangent is meeting the radius, at this point, this will create a 90 degree. This will create a 90 degree. Remember, the 90 degree angle will be at both sides because a straight line creates 180 degree. A straight line creates 180 degree. So if it is a 90 degree on the right hand side, so it will be 90 degree on the left hand side as well. So let's just see the tangent that we created. So if I just say that a radius is created on all the circles. So at this point, you need to understand that a 90 degree will be created when radius and the tangent will meet. A 90 degree will created when the radius and the tangent meet. A 90 degree will be created when the radius and the tangent will meet. So when the radius and the tangent will meet, it will always create what? A 90 degree angle, because it will be meeting two perpendicular lines at one particular point. It will meet two perpendicular lines at one particular point, where it will always create what? 90 degree angle. Okay, ji. So up till now, what we have done is we have done three properties. Number one was isosceles property. Number two was diameter meeting two chords, which is angle in the same in the semicircle. Then we did radius meets the tangent. Now we are working upon fourth one, which is when two radius meet two tangents. In other, angle from same point. Angle from same point. So what does this property state? So let's just work upon when two radius meets two tangent. It creates quadrilateral. It creates a quadrilateral. When it creates a quadrilateral, sum of quadrilateral is always what? 360 degree. Sum of quadrilateral is always 360 degrees. Since sum of quadrilateral is 360 degrees, and we already know when radius meets tangent, it creates 90 degree. So when two radius meets two different tangents, so it will create two 90 degrees. So a sum will be equal to what? 2 into 90 degree should be equal to what? 180 degree. Which means out of 4 angles, 2 angles is equal to 180 degree because of 290 degrees. So remaining 2 angles will be, remaining 2 angles will always have sum of 180 degree. Now, considering the fact that it was the theoretical version of what? When two radius meets the two tangent. But if we just work through the diagram itself, let's say that this is your circle. In this circle, let's say we have this center of the circle, and there is a tangent moving. There is a tangent moving. Now, if you just see a tangent is meeting radius and another tangent is meeting another radius. So, working out truly, we know when the radius meets tangent, it creates what? 90 degree, and it creates a 90 degree as well. So, the most important point is that when the two tangents that meet, they meet at one point outside the circle. So with respect to four different points, number one is the center, number two are 290 degrees, and the number fourth one is the point outside the circle that is being met by two tangents. It is a four-sided figure which is known as your quadrilateral. So when you have two 90-degree angles, so you know that your sum of quadrilateral is 360. And when you have two 90 degrees, those will make up sum of what? 180 degree. So that means 360 degree minus 180 degree. 360 degree minus what? 180 degree. You will be left with what? 180 degree only. When you will be left with 180 degree only, you need to understand that these two angles will make a sum of what? 180 degree. That means if this is 60, this should be 120. If this is 40, this should be 140. If this is 20, this should be 160. If this is 170, this should be 10. Because these two angles will make sum of what? 180 degree. So considering this, that when the two tangents meet two radiuses and those two tangents meet at the point outside the circle, it creates a quadrilateral. With two radius meeting two tangents, it creates 290 degree. So remaining 180 degree will be what? The sum of the two remaining angles. The sum of the two remaining angles, which will be equal to what? 180 degree. So this property is property when two radius meets two tangents. Those two tangents meet outside the circle at one point. It creates a quadrilateral of the sum 360. Knowing the fact that two radius meets two tangent, it will have two 90-degree angles. So when we subtract them from 360 degree, we end up having 180 degree left. When we have 180 degree, that means those two angles that are left behind has the sum of what? 180 degree. So even if you have one particular angle, you can always get the second angle by subtracting the other angle. If I just say that if we need to know the angle, if this is 150, so we know that by subtracting it from 180, we get this angle as 30 degree. Let's just work upon the extended version of property number 4. when you have a circle, knowing the fact that this circle will be with what? Center of the circle, and this will have two radiuses, and it will also have two tangents, and those two tangents meet at point outside the circle. This will create 290°, right? Now, the extended property says if a line is extended from center of circle to the point where two tangents meet. In this case, what you need to understand is this is your center of the circle and this is your point where two tangent meet. If a line is extended from the center of the circle to the point where two tangent meets, this is what it is written. Now, connecting to that, if a line is extended from a center of the circle to the point where two tangent meets, it creates two equal triangles. It creates two equal triangles. So if we just see that, let's just extend the line here from center of the circle to the point where the tangent meets. From center of the circle to the point where tangent meets. Knowing the fact that if this is 90°, this is 90°. If this becomes x, so this is also x. And if this becomes y, this should be y as well. So let's just work upon the example. Let's say this is 120°. The entire angle is 120° and this entire angle is what? 60° as per the property that we did here, right? So if this is 120 and 160, I extended the line. This line is now extended. So if this entire angle is 120, then this should be 60 and this should also be 60. That means this should be 30 and this angle should also be what? 30. So that particularly means that you will always be dividing the angle into two equal angles. 120 is divided into two equal parts. 60 is divided into two equal parts. That is known as your 30-30. If you see, 60 plus 30 creates what? 90°. So 90 plus 90 is what? Sum of triangle is what? 180°. This is 90°. 30, 90 plus 30 is 120. 120 plus 60. This also creates what? Sum of 180°. And 180 plus 180 will make sum of what? Quadrilateral. So that means quadrilateral is now divided into two equal triangles. Quadrilateral is divided into what? Two equal triangles with the help of extended line from the center of the circle to the point where tangent meets. So this is the extended version of property of what? Two radius meets at two different tangents. So property number 5. Now this is most important property, what I believe, where it says angle at center of circle is twice angle at circumference. Now, this is important considering the fact that to understand this property, you need to understand the entire concept. But before that, you need to understand that it has three types of diagram that are linked with this. There are three types of diagram that are linked with this. The three types of diagram has common thing which involves that 3 points are on circumference and one point is at center of circle. 3 points are on circumference and 1 point is at center of the circle. This is the first common thing. The second common thing is lines that meet only center will have angle which is twice. Line which meets circumference will have angle half the center angle. Now, this means that let's just work upon the types of the angles at the center of the circle and is twice the angle at the circumference, and also knowing what angle is twice and what angle is the singular. Let's just work upon the triangle itself. Let's say we have this triangle, we have this circle. This circle has a center of the circle as well. In this center of the circle, we know that there is a diagram which has 3 points on the circumference and 1 point at the center of the circumference. Now, point number 1, point 2, point 3. These 3 points are on the circumference and this point is at the center of the circle, right? Now, knowing this, that the lines that meet the center of the circle will be twice. So this angle should be what? Twice. And the line that will meet the circumference will be what? Half of it. Now you need to understand this. Even these two lines are also meeting what? Circumference. These two lines are also meeting circumference, but we did not take half of the center because out of these two lines, one line is meeting what? Center. So at this concept, what you need to understand is the only line that meets the circumference, will be half, not the line that meets the center. Even these two lines are meeting the circumference, but the line extended meets the center. So we can't take this angle as half. This will not be half. This angle will be half because the line is extended. These two lines does not meet the center of the circle. And when these two lines meet at the point on the circumference, it will be what? Angle which is half the center of the circle. So this is one type of the angle, even if, let's take the example. If this angle is 100, this means this angle should be 50. If this angle is 200, this angle should be 100. If this angle is 150, just an example, then this angle should be 300. So that means the angle at the center will always be twice the angle at the circumference. So this is one type of the diagram where 3 points are meeting at the circumference and 1 point is meeting at the center of the circle. Let's just work upon the second type. Your second type is when there's a center of the circle, a line extends from the center of the circle, meets the points here. Now, in this particular shape as well, if you see 3 points, 1, 2, 3 points are meeting at the point on the circumference. 3 points are meeting at the point on the circumference. And there is 1 point on the center of the circle. So the property that we wrote down, 3 points are on the circumference and 1 point at the center of the circle, that meets this diagram as well. 3 points on the circumference and 1 point at the center of the circle. And if you just look at this line and this line meets the center of the circle, so this should be what? 2x. Will we consider this as x? No. Why? Because this line meets the center. So obviously when the line meets the center, we cannot take this as x. Even this angle cannot be taken at x because the line with this angle meets the center of the circle. Only this angle will be considered as what? X, because these two lines do not meet the center of the circle. So when the lines do not meet the center of the circle, at that particular angle will be half the angle at the center of the circle. Referring it again, if you just need to understand this, that these two lines are meeting at the circumference, but one of the line is meeting at the center of the circle, so this angle cannot be half. Even these two lines are meeting at the point of the circumference, but one of the line is meeting at the center of the circle, so this cannot be half again. But if you look at these two lines are meeting at the circumference, and considering that these two lines are not meeting the center of the circle, this will be taken as what? Half angle. And half angle of what? Half angle of the center of the circle. Let's just take an example. Let's say that this is 50. So this angle should be what? 25. If this is 40, this angle should be what? 20. If this is 10, then this angle should be what? 20. The angle at the center is twice the angle at the circumference, considering this as type 2 shape of this particular property. There is another type of shape that will be used in this case. Let's say this is 2x, this is x again. The third type of shape, it has the center of the circle again. It has the center of the circle. If you note, the line will be extended from the radius. Here we go. Now, in this property as well, if you just look about it, you can see that first point, second point, third point. 1, 2, 3. These 3 points are meeting at the circumference. And there is a point on the center of circle as well. So that means angle at the center of the circle is twice the angle at the circumference. These two lines meet at the center of the circle. I repeat, these two lines meet at the center of the circle. So remember, this angle will be known as 2x. We'll be taking the outside angle. Whereas, if you just look at this, these two lines only meet at the circumference. These two lines does not meet the center of the circle. So this angle will be known as what? Half the angle at the circumference. This angle will be known as the half the angle at the circumference. That means that if this is 200, this angle should be known as what? 100. If this is 100, this angle should be known as what? 50. Because this angle will be half the angle at the circumference. So these three type of shape, let's just write this thing down. This is type 3. This becomes what? Type 2. And this becomes what? Type 1. So in this property, there are 3 type of diagrams that are used, and where you need to understand that the angle at the center of the circle is twice the angle at the circumference, where in this property, 3 points will be meeting at the circumference, 1 point will be meeting at the center of the circle. The angle which will be twice will be the angle when the 2 lines will meet at the center. That point will be twice, whereas the angle which is half will be the one where the 2 lines will only meet at the circumference. It will not meet at the center of the circle. That particular angle will be half the angle at the center of the circle. If you just look at the comparison of all the properties that we did in this lecture, you need to understand that in all the properties, you have one common thing. And that common thing is the center of the circle. Your isosceles property has the center of the circle. Your angle in the semicircle has the center of the circle. Your diameter and 2 chords have the center of the circle. Your radius and tangent has the center of the circle. Your 2 radius and 2 tangents have the center of the circle. Similarly, the angle at the center of the circle is twice the angle at the circumference, also has the center of the circle. So the most common point in these particular properties are that you have the center of the circle.